All right, so in this one right here, we got that these two triangles are similar, so we're just going to practice some basic skills of similar triangles. So we want to find the measure of TEC. All right, TEC. All right, so really what we're doing is finding this small red triangle, excuse me, and then we got this big blue triangle. Well, hold on. Let me undo that. So BTW is the big one. ETC is the small one. So really we need to find angle E. Notice how that corresponds to angle B. Angle B is 79, so TEC is also 79 degrees. All right, so 79 degrees. All right, now it wants me to find TCE. And for that, we just do the triangle sum theorem. So off screen, I'm just doing some quick calculations. And since all the angles in the triangle add up to 180, TCE must be 67 degrees. All right, cool beans. Now it needs the length of ET. All right, now we need the length of ET. So let's look at stuff. A couple ways to do it. I can just say, well, I have 12 and 20. All right, those are side lengths of the big blue triangle. I need to compare those to 3 and TE. So I can say, well, 12 to 20 in this big triangle compares to 3 to ET in the small one. From here, I just cross multiply. And it's 5. Cool beans. All right, if TE is 5, well, now this becomes a unit 1 problem where we did segment addition postulate. TE is 5. The whole base is 20. So what's BE? Well, what's 20 minus 5? 15. So that's how you solve that problem. All right, looking at this one right here, describe and correct the student's error in writing the similarity statement. All right, so it's saying triangle ABC is similar to triangle PQR by side angle side similarity theorem. All right, well, let's investigate. All right, so we have included angle 86 and 86, so the included angle part seems to be legit. Now let's do corresponding sides. Well, 15 to 18. Let's just do the smaller value over the bigger value is going to equal, it should equal, again, there's some kind of error we got to identify, 20 over 24. Is this true? Well, let's cross multiply and see if we get the same number. 15 times 24 is 360. 18 times 20 is 360. All right, so sides are proportional. Well, maybe it's something in the similarity statement itself. All right, it starts with A. A corresponds to, actually, it should be R. So right here, it should be triangle R. Those angle A and angle R are corresponding, then Q, then P. All right, so describe and correct the student's error in writing the similarity statement. It should be triangle ABC corresponds to, or is similar to triangle RQP. And that's just based on which angles correspond to which. Notice how A is the side length with the smaller number up to 86 degrees. R is the side length with the smaller number up to 86 degrees. So that's why it should be that. All right, determine if each set of triangles similar. If similar, be sure to include the postulate or theorem that justifies the similarity. Side, 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 angle, angle, and write a similarity statement. So this one would be yes. All right. Now, notice how that has one arc, that has 2 arcs, but these are equilateral or equiangular. These are all 60-degree angles, every single one of them, 60, 60, 60, so on and so forth. All right. So yes, they are similar. Yes. And in fact, all angles correspond to each other in this one because they're all 60 degrees. And this is just by angle. All right. We have equiangular. We know two angles are 60 degrees, thus the triangles must be similar. All right. This one right here, we're going to simplify it just a tad, not go too overboard. But we'll compare this triangle and this triangle. We won't worry about the big triangle. All right, we'll save that stuff for later. All right. So what I'm going to do on this blue triangle is just do 15, 12, and 9. All right, and I'm going to make fractions. Notice how in this blue triangle, I went from big to small. So in this red triangle, I'm going to go from big to small. All right, I just listed the numbers, and if they are similar, these should all be the same proportion. 15 divided by 20, 0.75. 12 divided by 16, 0.75. 9 divided by 12, 0.75. They all ended up being 0.75. Thus, all the sides are proportional. It would be true for the bigger one as well, but I want to save some time, not go too crazy. But we could say, yes, triangle WXZ is similar to triangle XYZ by side, side, side. All right, all the sides are proportional, thus the triangles are similar. Same concept with this one. All right, I'm going to take these and do it from least to greatest, or greatest to least. 26, 24, 20 equals fraction bar, fraction bar, fraction bar. Now let me order these right here, 39, 36, and 30. Now what numbers is this going to spit out each and every time? They're all 2/3. All right, they all equal 2/3. So yes, similar by side, side, side again. I can say triangle LMN, is similar. Well, 20, what corresponded to 20? That was 30. So I can say that was Y, ZX. That one was a little quirky. All right. L corresponds to Y. M corresponds to Z, and N and X. All right, and this last one, well, this is kind of like the same one as above. We could make this really complicated. I'm just going to keep it a little bit simpler. We'll just look at the two smaller ones. This must be 32 degrees. That must be 58 degrees. We could elaborate and we'll say that's a right triangle. So there's actually 3 triangles going on right now. We're only going to focus on the 2 smaller ones. Keep it a little simpler for now. Hold on, CFD corresponds to DFE by